Hello students, welcome to Saurav Sir's classes. The topic of this video is time, speed and distance. So let us start with the introduction of these terms. Here, time is defined as the duration during which an object completes its journey. Speed is the distance covered by an object in 1 unit of time, and distance is the path traveled by the object during its journey. The relationship between time, distance and speed is given by distance, which is denoted by d, is equals to speed into time. S denotes speed and t denotes time. So distance is equals to speed into time. Now if we keep speed as constant, then distance is directly proportional to time when speed is constant. Similarly, when time is constant, then distance is directly proportional to speed, and when distance is constant, then time is inversely proportional to speed. So if the ratio of speed between A and B is given by x is to y, then the ratio of time to cover the same distance is given by 1 by x is to 1 by y, which is equals to y is to x. Now the average speed is given by total distance by total time. Taken to cover the distance. However, if the same distance is covered at two different speed, that let us consider at x kilometer per hour and y kilometer per hour, if the same distance is covered in two different rate or in different speed, then the average speed in that case is given by 2xy divided by x plus y kilometer per hour. Then in this situation, the average speed would be given by 2xy divided by x plus y kilometer per hour. There are some other important formulas that will be very useful to solve the problems based on time, speed and distance. The first one being, suppose a man covers a certain distance with average speed of x kilometer and was late by t1 minutes. However, if the speed was y kilometer per hour, then he would have reached his destination t2 minutes earlier. Then the distance that the man covers is given by the formula x into y divided by x minus y into t1 minus t2 kilometer. Next formula states that suppose there are two persons A and B that are running from two different points in opposite direction and they have started at the same time. Suppose A is running in this direction and B is running in this direction, and they have started running at the same point, and after passing each other, they complete their journey in X hours and Y hours. That is, when they finally pass each other, suppose they passed each other at this point, then they cover the remaining journey in X and Y hours. That is, A covered this journey in X hour and B covered this journey in Y hour. Then their speed, that is the ratio of their speed, is given by root y is to root x. So the ratio of their speed is given by root y is to root x, where x and y are the time taken by A and B to complete the remaining journey, respectively. In the next formula, suppose there is a policeman who sees a thief at a distance of d, and he starts chasing the thief who is running with the speed of a, that is the speed of thief, and the policeman is chasing the thief with the speed of b, where b is greater than a. Then the distance covered by the thief when he is caught is given by. Now suppose the policeman was in the point A when he sees the thief. The distance is d. I said that at the distance of d. So now the thief is running with the speed of a, that is st is equals to a, and policeman is running with the speed of b, that is sp is equals to b, where b is greater than a. Now suppose he caught it at this point, then this distance is the distance which the thief ran before he got caught, and this distance is given by the formula d into a divided by b minus a. So this is the formula, and the distance covered by the policeman, suppose it is denoted by dp, is equals to d plus dt, where dt is the distance travelled by thief before he is getting caught, which is denoted by the formula, which is given by the formula d into a divided by b minus a. In the next formula, suppose a person reaches a certain distance, say d, with speed a, and gets late by t1 time, and when he increases the speed by b, that is his new speed will become a plus b, and he covers the same distance, and this time gets late by t2 time, then the distance covered by that person is given by d is equals to a by b into a plus b into t1 minus t2. So this is the distance. Now let us suppose that When he increases the speed by b, he covers the distance and reaches the destination t2 time earlier. In that case, the distance would be given by d is equals to a by b into a plus b into t1 plus t2.